Welcome. Tonight, we are going to talk about the end of everything. Not in a frightening way. Not in the way of warnings or urgency or things left undone. In the way of standing at the edge of an enormous, quiet ocean at night, feeling the vastness of it, the age of it, the absolute indifference of it, and finding, somehow, that it makes you feel more still, more held, more at peace. The universe is going to end. This is true, but the ending is so far away, so slow in its arrival, so patient in its unfolding, that the word ending barely applies. What science describes is not a sudden catastrophe, not a wall of fire, not a moment of violence. What science describes is a long, slow, breathtaking exhale, a dimming, a quieting. The universe, after 14 billion years of extraordinary noise and light and heat and birth, gradually, gently, over timescales so vast they have no name in any human language, growing still. And there is something in that image, if you let yourself feel it, that is not terrifying at all. It is familiar. It is what you are doing right now. After a long day of light and noise and heat and motion, you are dimming. You are quieting. You are doing, in miniature, what the universe itself will one day do in full. You are ending your day. And it is the most natural thing in the world. Think about what brought you here. The universe is 13.5 billion years old. It has been burning and building and exploding and assembling since before the concept of time had anything to measure. Stars have lived and died. Galaxies have collided and merged. Black holes have grown to incomprehensible size at the centers of enormous structures of light. And through all of it, the universe has been moving towards something. Not destruction, completion. Tonight we are going to drift through that completion together. Not in a rushed or anxious way. Slowly, gently, the way the last light of a fire settles into warm embers before the dark. And every single fact, every idea, every image has been chosen for one purpose. To remind you that endings are not the opposite of beauty. They are its final form. You don't have to be afraid of anything tonight. The universe has billions of years left. Trillions, in fact. More time than the human mind can hold. And in all of that time, you have this moment, this breath, this warmth, this quiet. Take one slow breath now and let the day go. Close your eyes, if they are not already closed. Let the voice carry you, and let the universe show you that even the end of everything is something you can rest inside. Before we go anywhere tonight, let us correct one thing. The end of the universe is not an explosion. It is not a wall of fire rushing toward us at the speed of light. It is not a cosmic catastrophe arriving without warning. It is not the kind of ending that announces itself with noise and violence and the sudden absence of everything. The end of the universe, as best as science can describe it, is the quietest thing imaginable. It is a process already underway, not urgently, not dangerously, but steadily, patiently, in the way that all truly enormous things move so slowly that a human lifetime, placed against it, would not register even as a flicker. The universe is not exploding outward toward destruction, it is exhaling. Think of the largest breath you have ever taken. A breath so deep it filled every part of you, your chest, your belly, the spaces between your ribs. And then the exhale. Long, slow, the air leaving not in a rush but in a gradual, complete release. The body settling. The muscles softening, the noise of the inhale giving way to the quiet of the outbreath. The Big Bang was the inhale. Everything since every star that has ever burned, every galaxy that has ever formed, every atom that has ever combined into something new and beautiful, all of it has been the breath moving outward, expanding, dispersing, cooling, and the end, whenever it comes, in whatever form science eventually confirms, will be the exhale completing itself, not a catastrophe, a conclusion. There is something in that framing that changes everything about how the topic feels. An explosion ends in wreckage. A breath ends in stillness. And stillness, as you are discovering right now, is not nothing. Stillness is what remains when all the noise has finished. It is the baseline, the ground state, the thing that was there before the first star ignited and will be there in some form, quiet and vast and real after the last one goes dark. Scientists who study the far future of the universe speak about something called thermodynamic equilibrium. It is the state in which all energy has been distributed as evenly as possible, in which no more work can be done, in which temperature differences, the engine of all activity, have finally resolved into perfect, uniform stillness. They sometimes call it the heat death of the universe, but that name is misleading. There is no heat in it. There is no death in the way we mean the word. The universe, after an incomprehensible amount of time and light and sound and motion, the universe is 13.5 billion years old. That number is so large that it defeats ordinary understanding. If you counted one number per second without stopping, it would take over 400 years to count to 13 billion. You would need to begin counting in the year 1600, continue through every generation that has lived since, and finish sometime in the early 21st century, just to reach the current age of the universe in seconds. And yet, compared to what lies ahead, 13.5 billion years is nothing. It is the very beginning of the story. Scientists who study the long-term future of the universe use a system of timescales so enormous they require their own language. They speak in powers of 10, not billions, not trillions, but numbers with so many zeros that writing them out would fill this page, and the next, and many more after that. The current era of the universe, the stelliferous era, the age of stars, will last for approximately 100 trillion years, 1 followed by 14 zeros. We are currently about 13 billion years into that 100 trillion year period. We are, in cosmic terms, very early in the morning. The stars have barely begun to burn, and after the stelliferous era ends, after the last star exhausts its fuel and fades, there are further eras waiting. The degenerate era, when the cold remnants of stars drift through the dark. The black hole era, when only black holes remain, slowly evaporating over timescales of 10 to the power of 67 years. The dark era, when even the black holes are gone and the universe is cold and still, and almost perfectly uniform. Each of these eras is longer than the last. Each one dwarfs what came before, the way an ocean dwarfs a raindrop. And through all of them, through every one of these vast, unhurried epochs, the universe will simply continue, changing, cooling, settling, moving toward the stillness it has always been moving toward. There is something deeply relaxing about this time scale, if you let it land properly. Nothing is urgent. Nothing is rushing. The universe has so much time that urgency itself becomes meaningless at this scale. Whatever anxieties arrived with you tonight, whatever unfinished things, whatever worries about tomorrow, they exist inside a sliver of time so brief, so vanishingly small against the backdrop of cosmic history, that they simply cannot carry the same weight here. Here, in the context of eternity, everything is early. 100 trillion years from now, the last star will die. Not with an explosion, not with a final dramatic burst of light sent across the cosmos as a farewell, simply with a slow, quiet fading. A red dwarf star, the smallest, coolest, most long-lived kind of star in the universe, will burn through the last of its hydrogen fuel. Its nuclear furnace will sputter. The light it has been producing for trillions of years will dim. And then, in the cold and the dark, it will become something else. Something quiet. Something that still exists, but no longer shines. Red dwarf stars are the most common stars in the universe. They are small, some only 1/10 the mass of our sun, and they burn so slowly, so carefully, so efficiently, that they can sustain nuclear fusion for trillions of years. While stars like our sun live for roughly 10 billion years, a red dwarf can burn for 10 trillion, or longer. They are the universe's most patient lights, and when the last one finally fades after a lifespan so long, it makes our sun's entire existence seem brief. The universe will enter a new kind of darkness, not the darkness between stars that we see when we look at the night sky. A deeper darkness, a darkness without any source of new light anywhere, a darkness in which the only things glowing will be the cooling embers of dead stars. And yet, even in that darkness, matter will still exist. The universe will not be empty. It will simply be changed. The atoms that made the stars will still be there, drifting, cold, spread across an enormous and ancient darkness, but still real, still present, still part of a universe that continues. There is something strangely comforting about the last star. The image of it, a small, dim red light, burning alone in an otherwise dark universe. Patient and steady, lasting longer than anything else in the cosmos, feels less like tragedy and more like devotion. It simply keeps going, for as long as it possibly can. It does not hurry its ending. It does not collapse prematurely or rush its fuel or burn brighter than it needs to in some final dramatic gesture. It simply shines until it cannot anymore, and then it rests. You are allowed to do the same. Tonight, you don't need to burn brightly. You don't need to produce light or heat or energy for anyone. You can simply be a small, warm thing in the dark, patient, steady, and when the time comes, whenever it comes, you will rest too. But not yet. For now, you are still burning. Softly, stars do not simply stop. They transform. When a star exhausts its nuclear fuel, when the hydrogen at its core has been converted to helium, and the helium to heavier elements, and the chain of fusion reactions that powered it for millions or billions or trillions of years finally reaches its end, the star does not vanish. It becomes something else, something quieter, something that persists. Our sun, in about 5 billion years, will exhaust its hydrogen and expand into a red giant, swelling to enormous size, engulfing the inner planets, glowing red and vast and ancient, before finally shedding its outer layers into space and collapsing into a white dwarf. A crystal sphere, roughly the size of Earth, composed mostly of carbon and oxygen, glowing faintly from residual heat with no ongoing fusion to sustain it. A white dwarf is a dying ember. It holds its warmth not from burning, but from memory, from the heat stored during billions of years of nuclear fire, now slowly radiating away into the surrounding darkness. Over trillions of years, it will cool. Its glow will shift from white to yellow, to orange to red, to infrared to nothing visible at all. Eventually, it will become a black dwarf. Cold, dark, dense. The compressed remains of what was once a star, still there, still real, still made of the same atoms that once burned in a stellar core, but no longer producing any light of its own. Astronomers believe no black dwarfs yet exist anywhere in the universe. The universe is not old enough. Even the oldest white dwarfs, formed from the first generation of stars, have not had time to cool completely. They are still warm, still faintly glowing, still carrying the residual heat of their stellar past into a present that has long since moved on. There is something in that image that moves quietly through the chest. These ancient cooling stars, the oldest things in the universe, still holding their warmth across incomprehensible stretches of time. Not burning, not bright, but not cold yet either. Still warm from something that ended long ago. You know that feeling. You carry warmth from things that have ended too, from people and places and moments that are no longer present in their original form, but that left something in you, a residual glow, a stored heat that has not yet fully dissipated. That warmth is real. It does not require the original fire to keep existing. It simply persists, as the white dwarfs persist, quietly in the dark. Still warm from something ancient. Still here. The universe is getting larger. Right now, as you lie here, as you breathe. The space between galaxies is stretching, not because galaxies are moving through space, but because space itself is expanding. The fabric of the cosmos is growing, slowly and continuously, in every direction simultaneously, carrying everything within it further from everything else. Edwin Hubble discovered this in 1929. He was studying distant galaxies through a telescope at the Mount Wilson Observatory in California, measuring their light. And he noticed something extraordinary. The light from distant galaxies was shifted toward the red end of the spectrum, the same kind of shift that happens to sound when its source is moving away from you, the way an ambulance siren drops in pitch as it passes. The galaxies were receding, all of them, in every direction. The universe was expanding. This discovery changed everything. It meant the universe had a beginning, a moment when everything was compressed into an unimaginably small and hot point. Before the expansion began, It meant the universe had a history. And it meant the universe had a direction, not a purposeful direction. Not a direction chosen by anyone, but a physical tendency built into the fabric of space itself, toward greater size, greater separation, greater emptiness. In 1998, astronomers discovered something even more surprising. The expansion is accelerating, not slowing down, as gravity would suggest, not holding steady. Accelerating, the universe is expanding faster and faster, driven by something called dark energy, a mysterious property of space itself that pushes outward against gravity, winning the contest in the long run, carrying galaxies away from each other at speeds that will eventually exceed the speed of light. Not the galaxies moving faster than light, but the space between them growing faster than light can cross it. Eventually, the most distant galaxies will recede beyond our observable horizon. Their light will never reach us again. The universe, as seen from any one point within it, will appear to shrink not because space is collapsing, but because the expansion has carried everything beyond the reach of light. The universe will become, to any observer within it, a smaller and lonelier place, and yet the universe itself will be larger than ever. Vast, still expanding into its own quiet enormity. There is something in this image that asks to simply be felt. The universe making more room, stretching itself out, creating space. That is what you are doing right now, in your own small way. Making room inside yourself for the quiet to arrive. Let the space grow. Let it expand gently, in every direction, until there is nothing left but stillness. In approximately 5 billion years, our sun will begin to die. Not suddenly, not violently. In the slow, patient, inevitable way that all stars of its size eventually do, running through its fuel, changing its structure, becoming something new before finally growing dark. The sun today is roughly halfway through its main sequence life. It has been burning hydrogen in its core for about 4.5 billion years, and it has approximately 5 billion years left before the hydrogen runs out. In cosmic terms, our star is middle-aged, stable, steady, going about its work with the same reliable consistency it has maintained since the solar system formed from a collapsing cloud of gas and dust. But in 5 billion years, the hydrogen at the core will finally be exhausted. The core will begin to contract, growing hotter under the pressure of its own gravity. The outer layers of the sun will expand in response, swelling outward, cooling as they go, turning red. The sun will become a red giant, growing to perhaps 100 times its current size, swallowing Mercury and Venus, and possibly Earth. The Earth as we know it will not survive this, but the atoms that make up the Earth will. Every atom in the rock beneath your feet, every atom in the ocean and the atmosphere, and the living things that move through both, all of it will persist, scattered by the red giant's expansion, dispersed into the surrounding space, drifting through the galaxy as part of a new cloud of gas and dust, available eventually to be gathered again into new stars, new planets, new forms of complexity we cannot predict. The sun's story does not end with its death. It continues in everything the death releases. In 5 billion years, the sun will become a white dwarf, a cooling ember about the size of Earth, made of the compressed remnants of a stellar core. It will glow for trillions of years more, dimming slowly, giving its heat back to the universe in the most gradual possible way, and the atoms that were once the Earth will be somewhere else by then, in a new star perhaps, in a new world, part of something that hasn't happened yet. You are made of atoms that have already lived through one stellar life cycle. The carbon in your body, the oxygen in your lungs, the iron in your blood, all of it was forged in a star that died before the sun was born. You are already on your second life, perhaps your third. Rest in that tonight. You are older than you know. Long after the last star has faded, something will remain. Black holes. The most extreme objects in the universe, regions of space where gravity has become so strong that nothing, not even light, can escape, will outlast every other structure in the cosmos. While stars burn out and white dwarfs cool, and galaxies dissolve into scattered clouds of dark matter and stellar remnants, black holes will persist, growing in some cases, as they absorb whatever drifts within their reach. Sitting in the centers of what were once galaxies, now just enormous dark presences in an otherwise dark universe. Black holes do not burn. They do not consume fuel. They simply exist, holding their gravitational grip on the space around them, patient beyond any patience we can name. And yet even they are not permanent. In 1974, the physicist Stephen Hawking made one of the most extraordinary theoretical discoveries in the history of science. He showed that black holes, despite their reputation for absolute permanence, slowly lose mass over time. Through a quantum mechanical process now called Hawking radiation, black holes emit a faint thermal glow, not light escaping from inside the event horizon, but light created at the boundary by quantum effects, carrying energy away from the black hole and leaving it very slightly less massive than before. Hawking radiation is extraordinarily faint. For a black hole of stellar mass, the temperature of this radiation is a fraction of a billionth of a degree above absolute zero. For the supermassive black holes at the centers of galaxies, it is even fainter, so far below the temperature of the cosmic microwave background that the black hole is currently absorbing more energy from the universe than it is emitting. But in the far future, when the universe has cooled below even that faint level, the black holes will begin to lose mass faster than they gain it, and they will evaporate. Over timescales of 10 to the power of 67 years for stellar black holes, and far longer for supermassive ones, black holes will slowly radiate themselves away, getting smaller, getting slightly warmer as they shrink, until in a final brief burst of radiation they simply cease, and the universe will be left with nothing larger than subatomic particles, in a silence so complete it has no comparison in any experience available to us. And yet, even that silence is not nothing. It is the universe, having completed something extraordinary, having done everything it was going to do. There is a word in physics that describes the end of everything: entropy. It sounds technical, cold, like something that belongs in a textbook rather than a bedtime story. But entropy, understood properly, is one of the most poetic concepts in all of science. It is the universe's tendency toward evenness, toward balance, toward the slow, inevitable distribution of energy until everything is the same temperature, the same density, the same quiet state of perfect equilibrium. Entropy is the universe tidying itself. In the beginning, in the first moments after the Big Bang, the universe was in a state of extraordinarily low entropy. Everything was compressed into one place, concentrated, uneven, full of the potential energy that unevenness creates. Hot spots and cold spots, dense regions and empty ones. The kind of difference that drives activity, that powers engines, that makes things happen. And ever since, the universe has been moving toward evenness. Every fire that has ever burned has been the universe redistributing heat. Every star that has ever shone has been converting concentrated nuclear energy into diffuse light and warmth, spreading it across space. Every living thing that has ever metabolized food has been participating in the universe's great project of evening out its energy. We are all, in our own small ways, instruments of entropy, and the end point of this process, the state toward which the universe has always been moving, is called the heat death, a state in which all energy is perfectly evenly distributed, in which there are no more temperature differences to drive any process, in which the universe has reached its lowest possible state of useful energy and its highest possible state of entropy. Maximum evenness, perfect equilibrium, complete rest. The heat death is not hot. The name is misleading. The universe in this state will be extraordinarily cold, just barely above absolute zero, the temperature at which all molecular motion ceases. It will be dark. It will be still. It will be, in the most precise physical sense, at peace. And here is the thing about peace. It is not nothing. Peace is a state, a real, physical, describable state. The absence of conflict is not the absence of existence. The absence of activity is not the absence of being. The universe in heat death will still exist. It will simply exist in the way that a perfectly still lake exists, in the way that a sleeping body exists, in the way that a held breath exists in the moment before it is released. Scientists have several names for the possible endings of the universe: the Big Freeze, the Big Rip, the Big Crunch, the Big Bounce. Each one describes a different fate, depending on the properties of dark energy, the geometry of space, and forces we do not yet fully understand. The most likely ending, given what we currently know, is the Big Freeze. It is the ending that follows naturally from the expanding, cooling, entropy-increasing universe we inhabit. As the universe expands, it cools. As it cools, the available energy for any process decreases. Stars burn out. Black holes evaporate. Particles drift further and further apart. The temperature of the universe approaches absolute zero, asymptotically getting closer and closer without ever quite arriving, the way a line approaches a horizon it never reaches. The Big Freeze is not a moment. It is a direction. A long, slow, patient drift toward the coldest and stillest possible state of being. Not an event that happens on a particular date, but a condition that the universe approaches across timescales that make the current age of the cosmos look like the first tick of a clock that will run for an eternity. There is something strangely comforting about the Big Freeze as an ending. It is the gentlest possible conclusion to the universe's story. No explosion, no collapse, no violent reversal of everything that has been built over billions of years. Simply a gradual quieting, a dimming of lights that were always going to dim, a cooling of fires that were always going to cool. The universe does not end in trauma. It ends in stillness. And stillness, as we have said, is not nothing. Think of the deepest sleep you have ever had. Not a restless sleep, not a dream-filled sleep, but the kind of sleep that has no content, no images, no sounds, no sense of time passing. The kind of sleep from which you wake feeling that something complete and real happened in the dark, even though you experienced none of it consciously. The Big Freeze is the universe's version of that sleep, a state so still, so even, so perfectly balanced that nothing more can happen. Not because something has gone wrong, because everything that could happen has happened. Every star that could burn, burned. Every planet that could form, formed. Every life that could arise, arose. Every thought that could be thought was thought somewhere, by someone, in some brief warm moment between the Big Bang and the long dark. There is another possible ending, less certain than the Big Freeze, but worth visiting quietly, in the spirit of scientific honesty, and the strange comfort that comes from knowing even the more dramatic endings are gentle in their own way. It is called the Big Rip. It would occur if dark energy, that mysterious outward pressure woven into the fabric of space, grows stronger over time, rather than remaining constant. If the expansion of the universe accelerates not just steadily, but increasingly, at a rate that compounds upon itself, the consequences would eventually become extraordinary. First, galaxy clusters would be pulled apart. The gravitational bonds holding clusters of galaxies together would be overcome by the expanding space between them. Galaxies would drift away from each other, becoming isolated islands in an increasingly vast darkness. Then, individual galaxies would be pulled apart. The stars within them, no longer able to maintain their gravitational community, would separate. Each star would become its own solitary wanderer in an expanding void. Then solar systems, then planets, then molecules, then atoms. The expansion of space, growing faster and faster, would eventually overwhelm every force that holds matter together, even the nuclear forces binding atomic nuclei. In the final moments of a universe ending in a big rip, matter itself would be torn apart at the most fundamental level, and then nothing. Or rather, something very close to nothing. The quantum foam of space-time, expanding too fast for any structure to form. This sounds alarming, but here is the thing about the Big Rip. If it happens at all, it would happen approximately 20 billion years from now, more than the current age of the universe into the future. And the tearing apart of atoms would occur only in the final fraction of a second. Before the end, a fraction so brief it would register as nothing on any human scale of experience. Everything before that final instant would look, to any observer, like the ordinary universe simply continuing. Stars, galaxies, space, time. The comfortable fabric of a cosmos going about its ancient business. and the final instant itself would be, in its own strange way, complete. The universe expressing its expansion to its ultimate conclusion. Not cruelty, not punishment, simply physics, following its own logic to the end of the line. There is something almost mathematical about its cleanness, and mathematics, at its deepest, is one of the most peaceful things there is. Let the big rip be what it is, a possibility, a distant one, a clean one, and let it go. Tonight, nothing is being torn apart. Everything is simply settling. Right now, the night sky contains thousands of galaxies visible to the naked eye, or rather, to telescopes sensitive enough to gather their ancient light. The Andromeda Galaxy, the Magellanic Clouds, the distant smudges of light in the Virgo cluster. The universe, as we currently experience it, is full of neighbors, full of light arriving from every direction, carrying the news of distant stars and ancient explosions and the ongoing business of a cosmos still very much in its active phase. But this will not always be so. As the universe expands, driven by dark energy, the most distant galaxies are already receding faster than light can cross the growing distance between us. Their light is already beyond our reach, already gone from any future view we might have of the cosmos. And as time passes, more and more galaxies will cross that horizon, their light forever unable to reach us. In approximately 2 trillion years, the Milky Way will exist in a universe that appears, from our position within it, to contain only the galaxies of our local group, the small family of galaxies gravitationally bound to us, moving together through a universe that has otherwise become empty and dark. The distant galaxies will not have disappeared. They will simply be unreachable, and eventually, even the local group will merge into a single large galaxy, the product of the Milky Way and Andromeda colliding and combining over billions of years. And that merged galaxy will sit alone in a universe that appears, to any observer within it, to be simply dark space in every direction. No neighbors, no arriving light from distant sources, just the stars of the merged galaxy, burning in a universe that has become, in the most literal sense, a private place. There is something in that image that is neither lonely nor frightening, if you sit with it long enough. Think of a night so clear and so dark that you cannot see the lights of any town or road or building. Just you, and the sky and the stars immediately above you. The world simplified down to its essentials. The universe reduced to what is close and real and present. That is what the far future will feel like. Not loss. Simplification. The universe, having been extraordinarily complex and busy for trillions of years, gradually becoming more intimate, more focused, more quiet. The long night between galaxies is not a tragedy. It is the universe finding its way to solitude. And solitude, in the right conditions, is not loneliness. It is the place where the deepest rest becomes possible. Tonight, you have found yours. Here is something extraordinary that physics suggests may happen, deep in the future of the universe. The protons themselves may decay. A proton is one of the fundamental building blocks of atomic nuclei. Everything made of ordinary matter, every rock, every ocean, every planet, every living body is made, at its most basic level, of protons and neutrons and electrons. If you took away the protons, there would be no atoms, no molecules, no chemistry, no matter as we understand it. And yet, certain theories in physics suggest that protons are not perfectly stable, that over an extraordinarily long period of time, perhaps 10 to the power of 34 years, a number so large it makes the current age of the universe look like a single heartbeat, a proton will spontaneously decay into lighter particles, a positron and a neutral pion, which will themselves quickly decay into photons. Light. The proton becomes light. If proton decay occurs, then in the far future, long after the last stars have faded, long after the white dwarfs have cooled, long after the black holes have begun their slow evaporation, the matter that remains, the cold, dark remnants of stars and planets and everything that was ever built in the universe, will slowly dissolve. Not explosively, not suddenly, one proton at a time, over timescales of incomprehensible length. The cold matter of the universe will transform itself into photons, particles of light that drift through the expanding darkness, spreading their tiny energy evenly through the growing void. Matter returning to light, structure returning to radiation. The universe gently undoing the complexity it spent billions of years building, not in destruction, but in transformation, releasing the energy locked in matter back into the open cosmos. There is a philosophical tradition in many cultures that speaks of all things returning to their source, the individual dissolving back into the whole, the temporary form releasing back into the formless ground from which it came. Proton decay is physics doing something that rhymes with that tradition. Every atom that ever existed, every structure that matter ever assembled, stars, planets, oceans, bodies returning over incomprehensible time into photons, into pure energy, into light spreading evenly through the universe. Nothing lost, only transformed, only returned. You are made of protons that have existed since the early universe. They have been part of stars, part of gas clouds, part of planets, part of living things, and now part of you. Temporarily, eventually they will return, but not tonight. Tonight they are here, arranged for this brief and precious moment into you. Imagine the last photon in the universe, not the last photon to be emitted by a star that happened long ago, when the final red dwarf sputtered and faded. Not the last photon from a black hole's hawking radiation that too has come and gone, in a universe that has moved beyond even black holes. The very last photon, the final particle of light remaining in a universe that has otherwise settled into its coldest, stillest, most diffuse state. A photon created perhaps in the final evaporation of the last black hole, now traveling through an expanding universe in which there is nothing left to absorb it. No atoms, no structures, no detectors, nothing to interact with. It simply travels, at the speed of light, as photons always do, through a universe that has become almost perfectly empty, the space around it expanding, the distances growing, the universe becoming larger and colder and more uniform with every moment. The photon passes through regions that were once crowded with stars and galaxies, and the extraordinary complexity of a living cosmos. Now there is nothing, just space, just expansion, just the photon, traveling. For how long? Perhaps forever. In some models of the universe's fate, a single photon in the void will travel for an eternity never absorbed, never interacted with, never coming to rest because there is simply nothing left to stop it. The last light in the universe, traveling alone through infinite dark. And yet, that photon carries something. It carries energy, real, physical energy, as real as any energy that has ever existed. Energy that was once part of a black hole, that was once part of a galaxy, that was once part of a universe teeming with stars and planets and on at least one small warm world, with creatures who lay in the dark and wondered about it all. The last photon carries, encoded in its frequency, the faintest possible echo of everything that came before it. Not consciously, not literally, but physically. The energy it carries is continuous with all the energy that has existed since the Big Bang. Transformed, yes, dispersed, yes, but the same energy, following the same conservation laws, moving through the same universe. Nothing was lost, only changed. There is a kind of peace in that. The universe's last light, carrying forward the energy of everything, traveling through the dark with no destination and no urgency, like a thought that drifts through a mind falling into sleep. There is a temperature called absolute zero. It is the coldest possible temperature in the universe, the point at which all thermal motion ceases, where atoms stop vibrating, where molecules stop moving, where the kinetic energy that we measure as heat has been reduced to its theoretical minimum. In the Celsius scale, absolute zero is minus 273.15 degrees. In the Kelvin scale, it is simply zero. Nothing in the observable universe has ever reached absolute zero. The coldest regions of space, the interiors of giant molecular clouds far from any star, reach temperatures of about 10 Kelvin. Extraordinarily cold by human standards, but still a measurable distance from the theoretical floor. Even the cosmic microwave background, the faint afterglow of the Big Bang that fills all of space, has a temperature of 2.7 Kelvin, a tiny but real amount of warmth, that pervades the entire observable universe. The universe, right now, is not quite at absolute zero. It is close, cosmically speaking, but not there. And in the far future, as the universe expands and the cosmic microwave background is stretched to longer and longer wavelengths, and lower energies, that temperature will drop. Not quickly, not dramatically, but steadily, asymptotically, approaching absolute zero the way a curve approaches a line it never quite touches. The universe will grow colder, and colder, and colder still, over timescales that defeat all human intuition about large numbers. The temperature of the universe will fall toward its theoretical minimum, not reaching it, perhaps never reaching it, but approaching it with the same patient inevitability that characterizes everything about the universe's long ending. Approach without arrival, getting closer always, without touching. There is something almost meditative in that image, a number that the universe spends an eternity approaching, drawing ever nearer, slowing as it goes, the gap between where it is and where it is going becoming smaller and smaller, but never zero. The approach itself becoming the thing, the journey towards stillness becoming its own kind of stillness. You have felt this. The approach of sleep is its own experience. Not quite awake, not quite asleep, the temperature of the mind dropping, the noise of thought getting quieter, the images becoming less coherent, the boundary between self and unconsciousness growing thinner. You approach sleep the way the universe approaches absolute zero, never quite touching the limit, and then, gently without noticing the moment of arrival, you are there. You have crossed the threshold without feeling it. As the universe eventually will, sound requires a medium. It is not like light, which can travel through the vacuum of space without anything to carry it. Sound is a pressure wave, a disturbance that travels through matter by pushing and pulling the molecules of whatever medium it moves through. Air, water, metal, stone. The medium transmits the wave, and the wave is the sound. Without a medium, there is no sound. Right now, the universe contains enough matter, enough gas between galaxies, enough plasma in galaxy clusters, enough substance of various kinds distributed through enough of space that certain kinds of pressure waves can propagate through it. Not sounds we could hear, not sounds that any living creature has ever perceived directly, but genuine acoustic phenomena, moving through the intergalactic medium in waves whose lengths and periods are measured in millions of light years and millions of years. The universe has a voice, in this sense, a very low one, a very slow one. But as the universe ages, as the gas disperses, as the matter grows more diffuse, as the density of the intergalactic medium drops towards zero, that voice will fade. The pressure waves will have nothing to propagate through. The universe will grow silent, not the relative silence of a quiet room, where the absence of loud sounds still contains the hum of air and the faint ring of tinnitus and the sound of your own breathing. A silence more fundamental than that. A silence in which there is no medium for any sound wave to travel through. A silence that is the physical consequence of a universe that has grown too thin, too cold, too diffuse to carry any disturbance. The last sound in the universe will not be dramatic. It will simply be the last propagation of the last pressure wave through the last sufficient concentration of matter before the medium becomes too thin to carry it further. And then nothing. No sound. Anywhere, ever again. And that silence will persist, for longer than any sound has ever lasted, through all the remaining eras of the universe's long ending, the cooling of the last remnants, the slow evaporation of the last black holes, the drift of the last particles. The silence will be there, vast, complete, and in its own way beautiful. You are approaching something like that silence tonight. The sounds of your day are fading, the voices, the notifications, the ambient noise of a life being lived, all of it is getting quieter. The medium of your waking mind is growing thin, and in the space where the noise was something still, something real. Listen, after the last star fades, the universe enters a new chapter. Scientists call it the degenerate era. Not degenerate in the moral sense, in the physics sense. Degenerate matter is matter compressed to such extraordinary density that its electrons can no longer move freely, locked into their lowest possible energy states by the pressure of quantum mechanics. White dwarfs and neutron stars are made of degenerate matter. They are the densest ordinary objects in the universe, not black holes, but the next closest thing. Stellar remnants so compressed that a teaspoon of their material would weigh millions of tons on Earth. The degenerate era is the age of these remnants. It begins when the last star fades roughly 100 trillion years from now, and it continues for an almost incomprehensible length of time afterward. Through this era, the universe will be populated not by shining stars, but by their cold, dark remains. White dwarfs, slowly cooling toward black dwarfs. Neutron stars spinning in the dark, their rotation gradually slowing as they radiate away the last of their rotational energy. Brown dwarfs, objects too small to ever ignite, the stars drifting cold and dark through a universe that has become almost entirely lightless. It will be a universe of remnants, of things that were, of matter that participated in the great stellar era and now persists in changed form, carrying forward in its structure the memory of what it once was. There is something deeply moving about a universe of remnants. We live in a remnant universe already, in a small way. The atoms in your body are remnants of stars that exploded billions of years ago. The mountains outside are remnants of geological processes that began when the Earth was young. The languages we speak are remnants of older languages, carrying forward patterns and sounds from people who lived and died long before us. We are surrounded by remnants. We are made of them. And in the degenerate era, the universe itself will become a place defined by what persists after the brightness is gone. Not a lesser universe, not a diminished one, a different one, quieter, darker, but still real, still physical, still governed by the same laws that produced the stars in the first place. The remnants will drift through the dark, patient and cold and real, as memories drift through a mind settling into sleep, not gone, simply changed. Simply quieter than they once were, present in a different way. You are surrounded by your own remnants tonight. The day's experiences, cooling now, settling, still real, simply at rest. Among the most extraordinary objects that will persist into the degenerate era are neutron stars. A neutron star is born when a massive star much larger than our Sun exhausts its fuel and collapses. The outer layers explode outward in a supernova, one of the most violent events in the universe. But the core collapses inward with extraordinary force, compressing protons and electrons together until they merge into neutrons. The result is an object roughly 20 kilometers across, about the size of a city, but containing more mass than our entire Sun. A neutron star is so dense that a single cubic centimeter of its material would weigh approximately 400 million tons. It is, in some sense, a giant atomic nucleus. Spinning, in the immediate aftermath of their formation, neutron stars spin extraordinarily fast, some completing hundreds of rotations per second, emitting beams of radio waves from their magnetic poles that sweep across space like cosmic lighthouses. These are called pulsars, and they are among the most precise natural clocks in the universe. Their pulses arrive with a regularity that rivals our best atomic clocks. But over time, even neutron stars slow down. The emission of radiation carries away rotational energy. The spin decreases. Gradually, over millions and then billions and then trillions of years, the neutron star's rotation slows from hundreds of times per second to once per second to once per minute to eventually stillness. A neutron star that has stopped spinning is called a dark neutron star. Cold, dense, dark, perfectly still. Drifting through the degenerate era universe with no light, no pulse, no rotation. Simply present. A city-sized sphere of the densest matter in the universe, moving silently through a universe that has otherwise grown very quiet. There is something about the image of a dark neutron star that feels like the physical embodiment of endurance. It began in violence, in the most dramatic explosion the universe produces, and it ends in stillness. The most extreme object born from the most extreme event, eventually settling into the most complete quiet. The journey from supernova to dark neutron star is the universe's most dramatic illustration of the path from chaos to peace. Everything turbulent, given enough time, grows still. Everything loud, given enough space, grows quiet. Everything spinning, given enough patience, comes to rest. You know this. You have lived through your own supernovae, your own explosive moments of transformation, and you have felt, afterward, the slow settling, the cooling, the gradual return to something like equilibrium. Tonight, you are further along that path, spinning down, growing still, almost there. Here is something that physics insists upon, even at the end of everything. Information is never destroyed. This is one of the most debated and most carefully defended principles in all of theoretical physics. The laws of quantum mechanics, at their most fundamental level, are time reversible. Any physical process can, in principle, be run backward. And this means that the information describing the initial state of any system is always preserved somewhere, somehow, even as the system evolves and changes. The universe forgets nothing. Every photon that has ever been emitted, every particle that has ever interacted, every structure that has ever formed and dissolved, the information describing all of it, is preserved in the quantum state of the universe. Not accessible, perhaps, not readable by any instrument we could build, but present, encoded in the correlations between particles, in the entanglement states that quantum mechanics produces whenever particles interact. Even the end of the universe does not erase this information. Even the heat death, that state of maximum entropy and minimum useful energy, preserves, in the quantum correlations of its constituent particles, the complete history of everything that has ever happened. The universe, in its final quiet state, carries within it the memory of every star that has ever burned, every planet that has ever formed, every ocean that has ever moved, every thought that has ever been thought by any conscious being anywhere in the history of the cosmos. Not consciously, not in any way that could be retrieved or read or experienced, but physically, mathematically, in the only language the universe has ever truly spoken. This is not a comforting idea in the ordinary sense. It is not warmth or light or the feeling of being held, but it is something. It is the universe's version of faithfulness, its refusal to let anything that has happened simply vanish without trace. Its insistence built into the deepest laws of physics that what occurs, occurred, that what was real, that what was beautiful, and that beauty leaves a mark on the state of the universe that persists even when the beauty itself is gone. You have been real. Everything you have experienced, everything you have felt, everything you have done, it has left its mark, not in any mystical sense, in the most literal physical sense possible. The universe is different because you are in it. The information of your existence is woven into its quantum state. The universe carries you, even when you are not aware of it, even when you are asleep, especially then, even in the deepest future, even in the most complete stillness the universe can achieve, something will remain. Quantum fluctuations. At the most fundamental level of reality, the quantum level, perfect stillness is impossible. The Heisenberg uncertainty principle, one of the foundational laws of quantum mechanics, states that you cannot simultaneously know with perfect precision both the position and the momentum of a particle. The more precisely you know one, the less precisely you can know the other. This is not a limitation of our instruments. It is a feature of reality itself. And one of its consequences is that even a perfect vacuum, even a region of space containing no particles, no radiation, no matter of any kind, is not truly empty. It seethes with virtual particles, pairs of particles and antiparticles that flicker into existence from pure energy, exist for an instant too brief to measure, and then annihilate each other and return to nothing. The vacuum is alive with these quantum fluctuations, always, even at absolute zero, even in the final state of the universe, even in the deepest dark of the heat death, when all matter has decayed and all black holes have evaporated, and all photons have dispersed beyond any possibility of interaction, the quantum vacuum will still be there, still fluctuating, still producing its endless, instantaneous, self-canceling pairs of virtual particles. The universe will never be completely still. Not because something is wrong, not because the ending has failed to arrive, but because stillness, at the quantum level, is simply not how reality works. Uncertainty is not a bug in the system, it is the system. The universe, at its most fundamental level, is made of probability and potential, rather than fixed positions and definite states. Even at the end of everything, the universe will be quietly, invisibly, perpetually possible. There is something deeply comforting in that. The end of the universe is not a wall, not a void, not an absolute nothing. It is a state of extraordinary quiet in which the most fundamental processes of reality continue, unseen, at scales too small to matter, but too real to ignore. A stillness that is not absence, a quiet that is not silence, a rest that is not death. You are made of quantum fields. Your body, your brain, the thoughts arising and dissolving in your mind right now. All of it is quantum mechanical at its foundation. All of it participates in the same irreducible uncertainty that will persist in the universe long after everything else is gone. Even in your deepest sleep, something in you continues. Here is the most extraordinary idea in all of cosmology. This may not be the only universe, and this universe's ending may not be an ending at all. There is a class of theories in modern physics speculative, unconfirmed, but taken seriously by some of the most careful thinkers in the field that suggest our universe is one of many, that the quantum vacuum from which our universe emerged is not unique, that the same processes that produced our Big Bang may produce others in other regions of what physicists call the multiverse, in other configurations of fundamental constants, in other expressions of the same underlying mathematics. And some of these theories go further. They suggest that even a universe that has reached heat death, that has settled into its final state of maximum entropy and minimum energy, is not permanently stable, that quantum fluctuations, given enough time, can produce spontaneous decreases in entropy, that in a universe that lasts long enough, something called a Boltzmann brain, a momentary fluctuation of order in a sea of disorder, might spontaneously arise. And further still, that given truly infinite time, quantum fluctuations in the false vacuum of a heat-death universe might nucleate a new Big Bang, a new region of low entropy expanding within the old, a new universe, born from the quantum restlessness of the old universe's final sleep, the end becoming a beginning, the silence incubating a new sound, the dark holding, in its quantum restlessness, the seed of new light. This is not certain. It may not be true. The physics here is genuinely at the frontier, where our mathematics reaches further than our ability to test it, where speculation is honest and humility is required. But it is possible, and possibility, at the end of everything, is everything. The universe does not definitively close. It may simply pause. A pause so long it defeats all human intuition about duration. A pause in which everything that existed cools and disperses and grows quiet. But a pause, not a stop. A breath held, not a breath ended. The universe resting, in the deepest possible way, before in some future so distant it makes the current age of the cosmos look like an instant something stirs again. Something begins again. Rest inside that tonight, not as a certainty, not as a promise, but as a possibility. The most calming possibility science has ever offered, that the end of everything is not the end of everything, that the universe, like you, simply needs to sleep. Here is a quieter kind of loss that the universe's ending brings. Not the loss of stars that exist now, but the loss of stars that will never get to be seen. Right now, the observable universe contains roughly 2 trillion galaxies. Each one holds hundreds of billions of stars. The light from most of those galaxies is already beyond our reach, already receded beyond the cosmic horizon, carried away by the expansion of space faster than light can cross the growing distance. We see those galaxies as they were billions of years ago, when their ancient light began its journey toward us. We will never see them as they are now, and as time passes, more will go. More galaxies will cross the horizon. More light will be lost to the expansion. The universe visible to any observer within it will shrink, not because the universe is getting smaller, but because it is getting larger faster than light can keep up. Future observers, if any exist trillions of years from now, will look out at a universe that appears almost empty, the stars of their own galaxy, burning in the dark, and beyond nothing visible. The rest of the universe hidden behind a horizon of expansion, its light forever unable to reach them. They will not know what they are missing. They will have no evidence that the universe was ever more crowded, more luminous, more full of neighboring galaxies than their own isolated home. We are fortunate to live when we do. We live in the universe's most visually spectacular era, the stelliferous era, when stars burn in every direction, when galaxies crowd the deep field images of our telescopes, when the universe is, by cosmic standards, brilliantly lit. This will not last. But it is here now, and there is something in that recognition that we live in the golden age of cosmic visibility, that the universe has never been more beautiful to look at than it is right now, that asks to be received with something like gratitude. You live in the most luminous moment of cosmic history. Every night you can step outside and see, with the naked eye, the light from stars in multiple galaxies. The Andromeda Galaxy is visible. The Milky Way arches overhead. The universe is showing itself to you with a generosity it will not maintain forever. Look up, when you can. Not tonight. Tonight you are resting. But sometime, look up, and know that what you are seeing is the universe at its most open, most radiant, most willing to be seen. A gift of timing, an accident of when you happen to exist. Everything cools. This is one of the most universal truths in physics. Heat flows from hot to cold. Energy disperses from concentrated to diffuse. The temperature of any isolated system, left to itself, will fall toward the temperature of its surroundings. This is the second law of thermodynamics, and it applies everywhere, at every scale, without exception. A cup of tea cools to room temperature. A star cools over billions of years from its initial collapse temperature to its surface temperature of thousands of degrees. A white dwarf cools over trillions of years, from the heat of its formation to the cold of the surrounding universe. And the universe itself cools, from the unimaginable heat of the Big Bang, through the warmth of the stelliferous era, through the cold of the degenerate era, through the deeper cold of the black hole era, and onward toward the asymptotic chill of its final state. Everything cools, and cooling is not only loss. Cooling is also the process by which complex structures become possible. The early universe, at billions of degrees, was too hot for atoms to form. It had to cool to allow electrons to bind to nuclei, had to cool further for molecules to form, further still for chemistry to occur, further for planets to solidify, further for oceans to be liquid, further for the temperature range in which proteins fold and DNA replicates and life becomes possible. Every stage of complexity in the universe's history required the previous stage to cool. You exist because the universe cooled to exactly the right temperature, not too hot for liquid water, not too cold for chemistry. The narrow, remarkable, improbable temperature range that makes biological life possible. You are a creature of the cooling, a structure that became possible because heat dispersed at exactly the right rate, to exactly the right degree. And tonight, you are cooling too. Your body temperature, which rises slightly during the day with activity and metabolism, will drop slightly during sleep. Your brain, which runs warm with the heat of constant activity, will cool as it reduces its workload. The electromagnetic noise of your waking mind will quiet as sleep approaches. You are joining the universal tendency, participating in the same process that cools stars and galaxies and the cosmos itself. Your cooling is not decline. It is preparation. It is the universe making you, in this small and intimate way, into the kind of thing that can dream. Let yourself cool tonight. Let the heat of the day dissipate. Let the temperature drop gently toward the warmth of sleep. You are doing exactly what the universe does. You are doing it beautifully. In the furthest future that physics can currently describe, after the stars, after the white dwarfs, after the neutron stars, after the black holes, after the protons themselves have decayed, what remains? The honest answer is, we are not entirely sure. But physics suggests several things. Electrons and positrons may remain. They appear to be genuinely stable, no known process causes them to decay, and they may persist essentially forever, drifting through an expanding universe as isolated particles separated by distances that grow with time, interacting with each other so rarely that a single interaction might occur once in a period longer than the current age of the universe raised to enormous powers. Photons may remain, drifting through the expanding dark, their energy so red-shifted by the expansion of space that their wavelengths are longer than the observable universe, and their frequencies approach zero. Not quite nothing, but so close to nothing that the distinction becomes philosophical. Neutrinos may remain, gravitons, the fundamental particles that interact least with everything else, the ones that have always been the most ghost-like presences in the physical world, may be the last things standing in a universe that has shed everything else, and the quantum vacuum will remain, seething with its invisible fluctuations, holding the potential for matter and energy without manifesting it, except in those briefest of quantum instants too short to measure. What remains when nothing remains is the fabric itself, space, time, the quantum fields that underlie all of physical reality, the mathematical structure of the universe, which has no mass, no charge, no temperature, and which therefore cannot cool, cannot decay, cannot disperse. The universe's final state is not nothing. It is the empty stage on which everything played out. Still there, still real, still, in some sense, waiting. There is a kind of peace in that image that is hard to name. The stage after the play has ended. The room after the conversation has finished. The page after the last word has been written. Not empty in the sense of meaningless, empty in the sense of complete, holding in its very structure the shape of everything that happened within it. You will feel something like this tonight, the moment when the last conscious thought dissolves and sleep fully arrives, the stage of your waking mind going dark, the room of your awareness falling quiet, not nothing, something, the ground of being, present and still, holding the shape of the day you lived even as the day's activity falls away. The stage remains. You remain, simply quieter than before, simply at rest. Somewhere in the far future of the universe, there will be a last black hole, not the largest, not the most massive, simply the last one remaining after all the others have completed their long, slow evaporation through Hawking radiation, the final gravitational remnant of the stellar era. The last structure in the universe massive enough to curve space significantly around itself. It will be alone. In a universe that has grown almost incomprehensibly large through billions of years of expansion, this final black hole will sit in a darkness so complete that the word darkness barely captures it. No stars, no galaxies, no gas clouds or nebulae, or the faint glow of cosmic microwave background radiation at any temperature detectable by any instrument we can imagine. Just space, expanding, and this one last massive object, slowly, infinitesimally slowly, radiating itself away. The process will take an almost unimaginable amount of time. For a black hole of stellar mass, complete evaporation through Hawking radiation takes approximately 10 to the power of 67 years. For a supermassive black hole, the kind that sits at the center of a large galaxy, the timescale extends to 10 to the power of 100 years or more. Numbers so large they require a different relationship with quantity entirely, but eventually it will end. The last black hole will reach a critical point where its mass has decreased enough that its Hawking radiation becomes significant. Its temperature will rise. Black holes get hotter as they get smaller, a counterintuitive feature of Hawking's mathematics. It will radiate faster, and in a final burst of energy, lasting perhaps only a fraction of a second by our standards, it will release the last of its mass as a spray of particles and radiation, and then it will be gone. The last object in the universe capable of significantly warping space will have ceased to exist, and the universe will be, for the first time in its entire history, truly flat, truly even. No mass concentrations anywhere, no gravitational wells, no curvature, just space, expanding perfectly, completely, finally flat. There is something about that moment, the universe finally achieving the flatness that its geometry always suggested it was approaching, that feels like completion rather than loss. A long equation finally balanced. A long tension finally resolved. The universe, after all this time, arriving at the simplest possible state. You will arrive at something like that tonight. The tensions of the day finally resolved. The equations of your worry finally balanced. Simply you, flat and still and real. Rest now. Stephen Hawking was 32 years old when he made the discovery that would define his legacy. It was 1974. He was already living with motor neuron disease, already in a wheelchair, already communicating with increasing difficulty, and yet his mind was moving into territory that no physicist had explored before: the intersection of quantum mechanics and general relativity. Two theories that do not naturally fit together, applied to the boundary of a black hole. What he found there was extraordinary. Black holes, he showed, are not perfectly black. At the event horizon, the boundary beyond which nothing can escape, quantum effects produce a faint thermal radiation. Virtual particle pairs, flickering into existence from the quantum vacuum, are sometimes separated by the event horizon. One falls in, one escapes. The escaping particle carries energy away from the black hole. The black hole loses mass. The black hole glows. Not visible, not in any way detectable by any instrument we currently possess. The temperature of Hawking radiation from a stellar mass black hole is so far below the temperature of the cosmic microwave background that the black hole is currently absorbing more energy than it emits. It will only begin to lose mass when the universe has cooled to temperatures far below its current level. But it glows. Faintly, patiently, inexorably. Hawking radiation is one of the most beautiful theoretical results in the history of physics. It connects gravity, quantum mechanics, thermodynamics, and information theory in a single elegant calculation. It suggests that black holes, the most extreme gravitational objects in the universe, are subject to the same thermodynamic laws as everything else, that nothing is exempt from entropy, that nothing holds forever. And it was discovered by a man who, by all physical rights, should not have been able to do the mathematics at all, whose body was being slowly taken from him, even as his mind reached into the deepest structures of space-time. There is something in that parallel worth sitting with quietly. Hawking's discovery about the slow, patient, inevitable dissolving of even the most extreme objects in the universe was made by a person experiencing his own slow, patient, inevitable physical limitation. And what he found was not despair. It was structure. It was the universe operating according to beautiful laws even at its most extreme. It was the assurance that even the things that seem most permanent are subject to the same patient processes as everything else. Everything changes. Everything radiates. Everything, given enough time, lets go. And in the letting go, the universe becomes something new, something quieter, something closer to rest. There is a way of holding the entire history of the universe in a single image, a breath. The Big Bang is the inhale. That moment, if moment is even the right word, when from a state of extraordinary compression, energy and space and time began to expand. The universe breathing in, filling itself, rushing outward with the force of everything that has ever been or will be. The expansion is the breath moving, carrying with it the heat of its origin, cooling as it goes, organizing itself into structure atoms, stars, galaxies, clusters. The cosmic web, the way a breath carries moisture and warmth from the body's interior into the air. The stelliferous era is the fullness of the breath, that sustained moment 100 trillion years long, when the breath is fully out, when the universe is at its most luminous and most complex, when every star that will ever exist is burning simultaneously in the greatest light show the cosmos will ever produce. And then the long exhale, the dimming of stars, the cooling of remnants, the slow evaporation of black holes, the dispersal of the last particles, the approach of the quantum vacuum to its final, resting state, the breath releasing, completely, without hurry, without drama, simply the natural completion of something that began with an extraordinary rush of energy and ends in the most complete possible stillness. And then, if the new universe theories are correct, a pause, a breath held, the quantum vacuum resting in its final state, holding all the information of the universe's history in the correlations of its particles, waiting for the fluctuation that will nucleate a new expansion, a new inhale, a new universe beginning. Let us return to our sun one more time and look at its ending, not with sadness, but with the particular kind of peace that comes from understanding a thing completely. The sun is 4.5 billion years old. In 4.5 billion more years, it will exhaust the hydrogen fuel in its core. This is not a sudden event. It will be preceded by billions of years of gradual change, the sun slowly brightening over its remaining life as helium accumulates in the core and the fusion reactions adjust. In approximately 1 billion years, the sun will be 10% brighter than it is today. In a billion more, 15%. The changes are so slow that no human civilization could perceive them directly. But they are happening. The sun is always, slowly, becoming something different than what it was. And 5 billion years from now, when the hydrogen is finally gone and the core begins to contract and the outer layers expand, the sun will swell into the red giant phase that will last for roughly 1 billion years. 1 billion years of slow expansion. 1 billion years of cooling outer layers glowing red against the dark. 1 billion years of a sun so large it fills most of the inner solar system. Then the outer layers will be shed, puffed gently away into space, forming a planetary nebula, a glowing shell of gas illuminated by the exposed core. And the core will be a white dwarf, dense, hot, glowing white against the dark, about the size of Earth, made of carbon and oxygen, the ash of the sun's long fusion reactions, carrying within its compressed structure the memory of 4.5 billion years of nuclear burning, now slowly, over trillions of years, radiating that memory away as heat. The sun's death will be beautiful. Planetary nebulae are among the most beautiful objects in the universe. Astronomers photograph them with telescopes and find in them extraordinary colors: the blues and greens of ionized oxygen, the reds of hydrogen, the gold of helium arranged in rings and shells and jets of extraordinary intricacy. The sun's death will be a work of art, made of light, lasting thousands of years before dispersing into the galaxy. And the atoms that made the sun, the ones it did not keep for its white dwarf remnant, will drift into space and eventually find their way into new stars, new planets, new forms. The sun does not end. It becomes, as all things eventually become something other than what they were. Here is a question that physics takes seriously. Does time end? Not in the sense of a clock stopping. Clocks are human inventions, and their stopping or starting tells us nothing fundamental about the nature of time itself. But in the deeper sense, is time a feature of the universe that persists into its final state? Or is it something that, like matter and energy, belongs to the active phase of cosmic history and will fade as that phase ends? The honest answer is that we do not know. General relativity treats time as a dimension of space-time, as real and structural as the 3 dimensions of space. In that framework, time does not stop. It continues, even in a universe that has reached heat death, carrying the empty universe forward into an ever more distant future, one moment following the next in an endless sequence that has no terminus. But quantum cosmology suggests something different. In some formulations of quantum gravity, the attempt to unify quantum mechanics and general relativity time is not fundamental. It emerges from deeper quantum relationships, a kind of collective illusion produced by the entanglement of quantum systems with each other. In this view, what we experience as the flow of time is not a feature of the bedrock of reality, but something that arises when quantum systems interact and change relative to each other. In a universe that has reached maximum entropy, in which all quantum systems are in their lowest energy states, and nothing is changing relative to anything else, time, in this sense, might simply stop, not with a jolt, not with a wall, simply with the cessation of the relative change that constitutes what we experience as time's passage, time dissolving into the timelessness from which it emerged, the universe returning to the condition it was in before the Big Bang. If before is even a meaningful word for something outside of time, when there was no change, no sequence, no before and after, just being, without time, without before or after, simply present, in a way that the word present barely captures, because present implies a now distinct from a then, and in timelessness there is no such distinction, simply is. This is as close as physics comes to the kind of stillness that contemplative traditions have described for thousands of years. The stillness beneath time, the ground of being that time arises from and returns to. You approach something like this in the deepest sleep, where time dissolves, where there is no sequence, where you simply are, without the scaffolding of before and after. That place is close now. Let yourself approach it. The Japanese have a word for it, mono no aware. It translates roughly as the pathos of things, the bittersweet awareness of impermanence, the gentle sadness and appreciation that arises from knowing that beautiful things do not last. The cherry blossoms are most beautiful precisely because they fall within a week. The sunset is most precious because it lasts only minutes. The moment of connection is most vivid because it will not return in exactly that form. Mono no aware is not despair. It is a deepened appreciation. It is what happens when you hold impermanence not as a threat but as the very quality that makes beauty possible. The universe, in its ending, offers something like mono no aware at the grandest possible scale. The stars are beautiful because they burn through their fuel and die. If stars burned forever, if they were truly permanent, unchanging features of an eternal universe, they would not be beautiful in the same way. They would be furniture, taken for granted, unnoticed. It is their transience that gives them their quality. The light of a star has traveled from a source that will one day go dark. The photon arriving at your eye began its journey in a nuclear furnace that has been burning for billions of years, and will burn for billions more, but not forever. You are receiving the light of something mortal, and that mortality is part of what makes it glow. The universe's ending does not diminish its beauty, it completes it. A story without an ending is not a story. A song that never resolves is not a song. A life with no arc is not a life. The ending is not the enemy of beauty, it is the frame that makes beauty possible, the container that gives the content its shape. The universe is a story with an ending, and that makes it the most beautiful story there is. Your life is a story with an ending too. Not tonight, not for a long time, if you are fortunate. But the ending is there as it is for all things. And rather than diminishing what you are, it gives you your shape. It is why the moments matter. It is why tonight this breath, this quiet, this warmth is not ordinary. It is why rest is not nothing. It is why sleep is not a waste of time, but one of the most real and precious things a body can do. You are impermanent, and impermanent things, held with awareness, are the most beautiful things in the universe. Rest in your impermanence tonight. It is the source of your beauty. Somewhere in the future of the universe, a thought will occur. Perhaps not in anything we would recognize as a mind. Perhaps not in anything biological. Perhaps in some configuration of matter or energy so different from what we know that the word thought barely applies. But if consciousness is a physical process, if awareness arises from the organization of matter and energy in certain patterns, then wherever in the universe the last such pattern exists, there will be the last conscious experience, a perception of some kind, an awareness of something, and then it will end, not with drama. The universe does not hold ceremonies for these things. Simply the last pattern dissolving back into the equilibrium it arose from. The last experience completing itself. The last awareness becoming unawareness. And a universe will continue afterward, in the way the universe continues expanding, cooling, moving toward its final state, but without anyone to notice, without anyone to whom it matters. This sounds melancholy, but hold it differently for a moment. The universe produced consciousness at all. This is, by any measure, extraordinary, a collection of particles following physical laws, particles with no awareness, no intention, no preference organize themselves. through the patient work of billions of years of stellar evolution and planetary chemistry and biological evolution, into beings capable of experience, capable of seeing the stars and wondering about them, capable of feeling the warmth of a fire and being grateful for it, capable of lying in the dark and finding peace in the thought of cosmic endings. The universe did not have to produce consciousness. There is no law that required it. And yet here we are, aware, experiencing the universe from the inside. The last conscious thought in the universe, whenever it occurs and whatever form it takes, will be the final expression of something extraordinary that the universe managed to produce in the narrow window between its hot young beginning and its cold dark ending. We are in that window now. We are among the conscious things the universe produced, and tonight, one of those conscious things you is choosing to spend a portion of its brief and precious awareness resting, recovering, preparing for another day of being awake in a universe that will not always contain anything awake. While we have been journeying through endings, something important must be said. Right now, as you lie here, stars are being born, not in the far future, not in some other universe. Right now, tonight, in stellar nurseries scattered across the Milky Way and in galaxies throughout the observable universe, clouds of hydrogen gas are collapsing under their own gravity. Pressure is building at their cores. Temperatures are rising toward the millions of degrees required for nuclear fusion to begin. Stars are igniting. At this very moment, new suns coming to life for the first time. Some of them will be small red dwarfs that will burn for 10 trillion years. Some will be massive blue giants that will burn furiously for only a few million years, before exploding as supernovae and seeding their neighborhoods with heavy elements. Some will be middleweight stars like our own sun, burning steadily for 10 billion years, perhaps warming planets in their habitable zones, perhaps giving rise to chemistry and biology and awareness. We do not know what will happen around those newly born stars, but they are burning now, right now, while you rest. The universe, even as it moves toward its eventual ending, is still in the full productive energy of its stellar era, still making new suns, still building new solar systems, still creating the conditions for complexity and life, and a brief, extraordinary experience of being aware in a physical universe. The universe is not winding down right now. It is burning. It is alive with stellar fire in a way that will not last forever but is absolutely, completely, gloriously present right now. And you are part of this moment, not the ending, the middle, the full, burning, luminous middle of the universe's most productive era. You were born at the right time, in the right era, in the right cosmic moment for a conscious being to exist. The ending is real, but it is so far away that it has no claim on tonight. Tonight belongs to the burning, to the new stars, to the universe still in its fullness, to you, warm and alive and breathing in the most luminous epoch the cosmos will ever know. There is a particular kind of peace that comes from deep time. Not from thinking about the future in the way we ordinarily do, planning, worrying, projecting, imagining scenarios that may or may not occur, but from genuinely placing yourself, for a moment, inside the full scale of cosmic time, from feeling, as viscerally as you can, what it means to exist inside a universe that is 13.5 billion years old and has trillions of years still ahead of it. From that perspective, everything changes. The anxieties of a single day, the things that went wrong, the things that were left undone, the conversations that didn't go the way you hoped, the tasks that wait for tomorrow, these are real. They matter in their context, but placed against deep time, they reveal their actual scale. They are small, not dismissibly small, not meaninglessly small, but small in the way that is actually comforting small, the way a pebble dropped into an ocean creates real ripples that are nonetheless absorbed into something immeasurably larger than themselves. Your worries are real, and the universe is 13.5 billion years old. Both things are true, and the second truth does not erase the first. It does not make your worries false or your pain irrelevant, but it places them in a context that shifts their weight. It gives you, for a moment, the perspective of deep time, the view from a timescale so large that even stars are brief, even galaxies are temporary, even the current era of the universe is just the opening act of a story that will unfold over trillions of years. From that perspective, tonight is not defined by what went wrong. Tonight is defined by the fact that you are here, alive, warm, breathing on a planet that formed from the remnants of dead stars, orbiting a sun that has been burning for 4.5 billion years, in a galaxy that will continue to exist for trillions more. Tonight is not a problem to be solved. It is a moment inside an incomprehensible vastness. And in that vastness, this moment, your breath, your warmth, your quiet is as real and as complete as anything that has ever existed. Nothing that happened today has diminished that. Nothing that will happen tomorrow can reach back and change it. Right now, you exist in the full, burning, patient, ancient, extraordinary universe. That is enough. It has always been enough. Rest inside the deep time tonight. Let it hold you. It is very good at holding. It has been practicing for 13.5 billion years. In approximately 4.5 billion years, something extraordinary will happen. The Andromeda Galaxy will collide with the Milky Way. This sounds catastrophic. Two galaxies, each containing hundreds of billions of stars, moving toward each other at approximately 110 kilometers per second. Drawn together by mutual gravity across a distance of 2.5 million light-years. But galaxy collisions are not what they sound like. The stars in a galaxy are so far apart, separated by distances of light-years, even in the densest regions, that the probability of any two stars actually colliding during a galactic merger is extraordinarily small. When Andromeda and the Milky Way pass through each other, the stars will largely miss each other entirely. What will collide is the gravitational structure, the dark matter halos, the gas clouds. The stars will be stirred. Their orbits will be disrupted. Stars currently in graceful circular orbits around the galactic center will be flung into new paths, elliptical, inclined, chaotic by the standards of what came before. The beautiful spiral structure of both galaxies will be destroyed in the encounter, replaced by something new, a merged galaxy. Astronomers call it Milkomeda. It will be an elliptical galaxy, large, smooth, without the dramatic spiral arms of its progenitors. Older-looking, calmer. The frantic star formation of the collision will eventually settle. The disrupted orbits will gradually, over billions of years, find new equilibria, and the merged galaxy will be home to all the stars that were once in both the Milky Way and Andromeda. A larger family, a different shape. The same stars, reconfigured. Our sun will almost certainly survive the collision. It will be in a different orbit afterward, probably flung into a more elongated path around the center of Milkomeda, further from the core than it is now. The night sky from any planets orbiting our sun will look completely different. The familiar constellations will be gone, replaced by a new sky populated by the combined stars of two ancient galaxies. A new home, different from the old one, but home. This is not the end of anything we love. It is a transformation. The universe rearranging its contents into something new, as it has done since the beginning, as it will continue to do until the very end. Let things be rearranged tonight. Let the familiar dissolve a little. What comes after transformation is not nothing. It is simply different. And different, given time, becomes home. There is a theory, speculative, controversial, held by a small number of physicists and philosophers, that deserves a quiet mention in the dark. It is called the Omega Point. First proposed by the mathematician and cosmologist Frank Tipler, it describes a possible far future in which the universe, rather than ending in cold stillness, ends in a collapse, a big crunch rather than a big freeze, and in which the energy available during that collapse is used by intelligent beings of unimaginable sophistication to perform an infinite amount of computation, an infinite amount of thought. The idea is that as the universe collapses and temperatures rise, the energy density increases without limit, and in that increasing energy, entities capable of processing information at faster and faster rates could, in principle, compress an infinite subjective experience into a finite period of objective time. Infinite thought before the end. infinite experience in the last moment. The omega point is almost certainly not how the universe will end. Current evidence strongly favors acceleration rather than collapse, making a big crunch unlikely. And Tipler's specific claims have been criticized extensively by physicists and philosophers alike. But the idea itself carries something worth holding. The notion that the end of the universe could be not a diminishment but a culmination, not a running down but a gathering up, not the extinguishing of thought but its ultimate flowering, everything that consciousness ever was, concentrated and completed in a final moment of extraordinary fullness. The ending as arrival rather than departure. The last moment as the most alive moment. There is a quieter version of this that you know personally. The moment just before sleep sometimes carries a particular quality of aliveness. The day's thoughts, released from the need to drive action, float freely. Images arise without effort. Connections form that the busy waking mind would never make. The threshold between consciousness and sleep is sometimes the most creative, most open, most genuinely alive moment of the day. The omega point, in miniature. The ending that is also a kind of completion. Let your mind do that now. Float in the threshold. Let the thoughts arise without following them. Let the connections form without capturing them. The ending of your waking day, if you let it, is not a shutdown. Science has been studying endings for as long as it has existed. The ending of chemical reactions, the ending of radioactive decay, the ending of stars, the ending of species, the ending of geological eras, the ending of universes. And in all of that study, across all of those scales and all of those time scales, science has found something consistent. Endings are transitions. Not one thing ceasing to exist, but one configuration of matter and energy transforming into another. Not a wall, but a door. Not a termination, but a passage. The chemical reaction ends and produces new compounds. The radioactive atom decays and produces new elements. The star ends and produces a nebula that seeds new stars. The species ends and its ecological niche is filled by something new. The geological era ends, and the new era begins with the survivors of the old. Nothing simply stops. Everything transforms. The second law of thermodynamics tells us that entropy increases, that order tends toward disorder, that useful energy tends toward diffuse heat, that the universe moves toward its final equilibrium. This is true and irreversible and real. But entropy is not destruction. Entropy is rearrangement. The order that existed before the ending does not vanish, it disperses. The information that described it does not disappear, it redistributes. The energy that powered it does not cease, it spreads. The universe's ending is the most complete possible dispersal of everything that has ever been. Not a loss, a distribution, everything shared equally across the entire fabric of existence. The most democratic possible conclusion. There is a generosity in that, if you hold it right. The universe, at its end, will have given everything it had to the space it inhabits, held nothing back, reserved nothing for itself, distributed its entire treasury of energy and information and history evenly, completely, without remainder. An ending of complete giving. The universe's final act as an act of openness. This is what you are doing tonight, giving the day back, releasing what you held, distributing the energy of your waking hours back into rest, into the body's quiet processes of repair and renewal, into the dreams that will rearrange today's experiences into tomorrow's understanding. You are practicing the universe's most fundamental gesture, letting go, completely, without remainder. If the multiverse exists, and many physicists take the possibility seriously, even if confirmation remains beyond our current reach, then our universe's ending is not the ending of everything. It is one ending among an uncountable number. In the eternal inflation model of cosmology, our universe is a bubble that nucleated within a larger inflating space. The inflating space continues around and outside our bubble, continuously producing new bubbles, new universes, each with its own physical constants, its own laws, its own history, its own ending. Some of those universes may have collapsed already. Others may be older than ours, others younger. Some may have different values of the constants that govern physics, different strengths of gravity, different masses for fundamental particles, different values of the speed of light, and in those universes, the physics of stars and atoms and life, if it arises at all, will be different from ours. Some may be empty from the start. Some may be so different that the very concept of ending does not apply to them in any meaningful way. And some, by pure statistical necessity, if there are truly infinite universes, will be very much like ours. We'll have stars like ours. We'll have planets like ours. We'll have perhaps creatures like us lying in the dark on warm nights, thinking about the end of their universe. The ending of our universe, in this picture, is a local event, significant to everything within it. But one conclusion among infinite conclusions, one story among infinite stories, and the space in which all of these stories are told, the eternal inflating background in which our bubble and all the others float, does not end with any of them. The medium persists. The stage remains. Even when the play within our particular bubble has run its course, the theater continues. Other plays are running. New ones are beginning. This is not meant to diminish the importance of our universe's story. A story matters even if other stories exist. Your life matters even though other lives are being lived simultaneously. The ending of something real is real, regardless of what else continues. But there is comfort in the knowledge that ending and ending of everything are not the same thing. Our universe will end, and something will continue. Something always continues. Sleep in that tonight. Something always continues. Here is something that physics cannot measure, but that the universe has produced nonetheless. In the stelliferous era, in this brief, burning, luminous window between the Big Bang and the long dark matter, organized itself into living things. And living things, through processes that began with chemistry and continued through evolution and culture, and the extraordinary complexity of brains capable of experience, produced something that has no counterpart anywhere in the known laws of physics. Love. Not as a mystical force, not as something outside of nature, but as an emergent property of matter arranged in very particular ways. The same atoms that form stars and planets and oceans, organized into nervous systems capable of attachment and care, and the particular quality of attention that one conscious being gives to another. Gravity holds galaxies together. Love in its own way holds people together. Both are invisible forces. Both act across distances. Both shape the trajectories of the things they influence. Both are, in their different registers, forms of the universe holding itself together. The universe produced gravity in the first fraction of a second after the Big Bang. It took almost 14 billion years to produce love. That timeline is worth sitting with. 14 billion years of stars and explosions and cooling and chemistry and evolution, all of it, in some sense, moving toward the emergence of something capable of caring about something else, capable of lying awake at night thinking about the people it loves, capable of feeling the warmth of connection as a physical sensation in the chest, capable of finding, in the thought of another person, a reason to face another day. The universe did not have to do this. There is no physical law that required love to emerge from matter. And yet, here you are, capable of it, practicing it, shaped by it in ways that the best physics in the world cannot fully describe. Whatever or whoever you carry in your heart tonight, carry them gently. They are part of what the universe spent 14 billion years working toward. They are, in their own way, as extraordinary as stars, as rare as conscious experience, as brief and as real as everything else in this luminous, temporary, beautiful universe. Hold them in your mind as you drift toward sleep. We have spent this journey moving through endings, through the deaths of stars and the evaporation of black holes, and the dispersal of matter and the approach of the universal cold, through the long dark that follows the last light. And if there is one thing worth taking from all of it, it is this: the darkness is not empty. The darkness of the far future, that vast, cold, still state toward which the universe is slowly moving, is not nothing. It is full of the quantum vacuum with its endless fluctuations, full of the information of everything that ever happened, encoded in the correlations of its particles, full of the mathematical structure of space-time itself, which has no temperature, no mass, no energy to dissipate, and which persists, full of the possibility of whatever comes next. The darkness is a fullness we have not learned to see, and the darkness of tonight is the same. The darkness of your room right now is not the absence of everything. It is the presence of rest, the presence of the quiet your nervous system needs to rebuild itself, the presence of the dreams your mind needs to process what it has experienced, the presence of the deep, ancient biological imperative to release the day and allow the body to do its nightly work of repair and renewal. The darkness holds you tonight, not as a metaphor. Physically, the air around you is real. The surface beneath you is real. The temperature of the room is real. The darkness itself has physical properties. The absence of light means the absence of photons stimulating your retina, allowing your brain to shift into modes of processing that are only possible in the dark. Your body knows what to do with darkness. It has been doing it for as long as bodies have existed. Longer than that, the rhythms of sleep and waking are built into living things at the cellular level. Older than the evolution of complex brains. Older than the development of eyes that can register the difference between light and dark. You are ancient in your relationship with darkness. Your cells know it. Your rhythms know it. Your body has been practicing this for hundreds of millions of years of evolutionary history. The darkness is home. Let it be home tonight. Close your eyes, if they are not already closed. Let the darkness hold you. You exist in the most extraordinary window of cosmic time. Not the beginning, when the universe was too hot and too simple for anything like you to exist. Not the middle distant future, when the stars will be dimming and the universe cooling toward its final state. Not the far future, when the last black holes will be evaporating in a darkness unimaginable to us. Now, the stelliferous era, the age of stars, the window roughly 100 trillion years long, in which the universe has organized its matter into nuclear furnaces that burn at the exact temperatures required for the elements of life to exist, for liquid water to persist on planetary surfaces, for chemistry to become biology and biology to become awareness. You exist in the only window in which existence, as you experience it, is possible, and you exist near the beginning of that window. We are roughly 13 billion years into a 100 trillion year era. Cosmically speaking, the party has just started. The vast majority of the stellar era lies ahead. More stars will burn. More planets will form. More life will perhaps arise in the universe's long and luminous future than has arisen in all of its history so far. You are early. You are part of the opening of something extraordinary. And yet you are here, conscious, aware, capable of wondering about your own existence and the existence of the universe around you. That awareness is not guaranteed by physics. The universe spent 13.5 billion years making the conditions for it possible. And in this particular corner of the cosmos, at this particular moment, those conditions produced you. Aware, alive, lying in the dark on a warm planet, breathing slowly, thinking thoughts that no other arrangement of matter in the history of the universe has ever thought in quite this way. This is the privilege of now, not the absence of difficulty, not the absence of pain or loss or the ordinary suffering of a human life, but the privilege of being here, of being the kind of thing that can be here, of having a now to be privileged by. The universe does not always produce consciousness. It has produced you. Receive that tonight, not with pressure or obligation, simply with the quiet recognition that you are here, in the right era, at the right moment, alive, and that is extraordinary. Right now, above the ceiling of your room, above the atmosphere of your planet, the universe is conducting its business. Stars are burning in the Milky Way, hundreds of billions of them, most too faint to see with the naked eye but present, real. Each one a nuclear furnace converting hydrogen to helium, releasing the energy that, at the right distance, warms planets and powers the chemistry of life. Somewhere above you, the Andromeda galaxy is drifting, still 2.5 million light-years away, still approaching, but so slowly that its motion is imperceptible on any human timescale. 1 trillion stars, moving toward 1 trillion more. Above you, the cosmic microwave background fills the sky, the ancient warmth of the Big Bang. cooled over 13.5 billion years to just barely above absolute zero. Present in every direction, the oldest light that exists. Above you, dark matter halos wrap the Milky Way in their invisible embrace, holding the galaxy's spiral arms in their graceful shape, providing the gravitational architecture that made the Sun's stable orbit possible, that made the solar system's long calm history possible, that made you possible. Above you, the universe is going about its ancient, patient, extraordinary business. Stars are being born. Stars are dying. Supernovae are scattering their heavy elements into new gas clouds. Black holes are pulling matter into configurations of extraordinary density. The cosmic web is slowly, imperceptibly shifting as dark matter flows through the universe along its invisible pathways. All of it happening above you, right now, while you rest. You do not need to participate. You do not need to hold any of it together. The universe is doing what it does, as it always has, as it will for trillions of years after tonight. And you small, warm, brief, conscious extraordinary are allowed to simply be inside it, not managing it, not understanding it fully, simply being here, beneath the stars, inside the universe, held by everything above and below and around you. The ceiling is between you and the stars, but the stars are there, and they are burning for you in the same sense that they burn for everything completely, without preference, without asking anything in return. Let us look at entropy, not as a force of decay or loss, or the running down of things, but as something else. Something that, if you turn it slightly in the light, looks like grace. Entropy is the universe's tendency toward sharing. Every hot object shares its heat with its cooler surroundings. Every concentrated energy disperses into its environment. Every ordered structure, over time, contributes its order to the surrounding disorder, until the difference between the two is resolved into evenness. Entropy is the universe refusing to hoard, refusing to maintain inequality of temperature or density or energy for longer than physics requires, moving always, steadily, irresistibly toward the state in which everything has an equal share. Stars share their energy with the planets around them, and the space around those planets, and the galaxy around that space. They burn their nuclear fuel not for themselves. Stars have no selves but unconditionally, in every direction without reservation. The Sun has been sharing its energy with the solar system for 4.5 billion years. It asks nothing in return, it simply gives, until it can give no more, and then it becomes a white dwarf, and it gives its residual heat, more slowly over trillions of years, until that too is shared completely with the surrounding universe. Total giving, without remainder. This is what entropy looks like when you remove the language of loss and replace it with the language of generosity. The universe moving toward perfect generosity, toward the state in which no corner is hotter than any other, no region richer in energy than any other, no structure more privileged than any other. The ending of the universe is the completion of its most fundamental project, the most equal distribution of everything it has. At the very edge of what physics can currently say about the universe's future, there is a kind of honest silence. We know the broad outlines. We know the universe is expanding and cooling. We know the stars will eventually burn out. We know the black holes will evaporate. We know that entropy increases. We know that the universe is moving toward a state of maximum equilibrium. Beyond that, the mathematics becomes uncertain. The quantum gravity theories that might tell us what happens to time at the end of the universe are not yet complete. The nature of dark energy, whether it remains constant or changes over time, will determine which of several possible endings actually occurs, and we do not yet know its nature fully. The question of whether information is truly preserved through the universe's evolution, or whether some process ultimately destroys it, remains one of the deepest open problems in physics. At the edge of the map, there is still unknown territory, and science, at its most honest, does not fill unknown territory with invented certainties. It simply says, here is what we know. Here is the boundary of our knowledge. Beyond this line, we are working carefully to find out more. That honesty is one of science's most beautiful qualities. It is also, in its own way, restful. You do not have to know how it ends. Nobody does, fully. The physicists who have devoted their lives to understanding the universe's fate are working at the very edge of human knowledge. And even they live with uncertainty about the final chapter. And they are okay. They sleep at night. They find meaning in the questions as much as in the answers. They have learned, as all genuine students of the universe eventually do, that living with an open question is not the same as living without ground to stand on. Let us trace it one final time. 13.5 billion years ago, a universe began. In its first fraction of a second, the fundamental forces separated. Dark matter was born. The laws of physics were written in the language of energy, so dense it defies imagination. In the first 3 minutes, protons and neutrons formed, then combined into the nuclei of hydrogen and helium, the lightest elements, the raw material of everything that would follow. 380,000 years later, electrons joined those nuclei and atoms formed. The universe became transparent. Light streamed free for the first time. The cosmic microwave background was released, the oldest light that exists. Still traveling, still present, still warm in every direction of the sky. Hundreds of millions of years later, the first stars ignited in the dark. Their light ended the cosmic dark ages. Their nuclear furnaces forged the first heavy elements: carbon, oxygen, nitrogen, iron, that matter needed to become something more than hydrogen and helium. Those stars died. Their heavy elements scattered into the galaxy. New stars formed from the enriched gas. Some of them had planets. 4.5 billion years ago, one of those stars, ordinary in almost every way, ignited in a quiet arm of a spiral galaxy. A disk of gas and dust surrounded it. The disk cooled and clumped into planets. The third planet from that star settled into the habitable zone. Water pooled on its surface. Chemistry began. 4 billion years ago, the first life appeared in those ancient oceans. 4 billion years of evolution followed. Single cells, multicellular organisms, the Cambrian explosion of complex life. Fish, land creatures, dinosaurs, mammals, primates. 200,000 years ago, something new appeared. Humans, conscious, curious, capable of language and art and science and love. Capable of lying in the dark and wondering about the universe they found themselves inside. And then, in an eye blink of cosmic time, from among those billions of humans who have ever lived you, this particular arrangement of atoms, this specific pattern of experience and memory and personality and awareness, here, tonight, alive, thinking, breathing slowly in the dark. 13.5 billion years of cosmic history led through a chain of causes so long and so intricate that no mind could hold it whole, to this moment, to you, to this breath. Rest in that. You are the universe's most recent surprise, and you are exactly where you are supposed to be. The universe is ending, but not tonight. Tonight the universe is burning. Stars are igniting in stellar nurseries across the Milky Way. Planets are forming around new suns. The cosmic web is slowly, imperceptibly shifting as dark matter flows through its ancient pathways. The expansion of space is carrying galaxies further from each other. But here in this galaxy, in this solar system, on this planet, everything is close and warm and real. The ending is real, but it is so far away that it belongs to a different chapter of the story entirely. You are in the early pages. The universe has not finished with the stelliferous era, has not finished producing stars and planets, and perhaps the extraordinary conditions that give rise to consciousness, has not finished the long, luminous, burning chapter of its history, in which things like you are possible, and the universe has not finished with you. Not tonight. Tonight, it needs you to rest, to let your cells repair themselves in the quiet chemistry of sleep, to let your memories consolidate in the strange theater of dreams, to let your body restore the resources it spent today being alive in the full and demanding way that being alive requires. The universe invested 13.5 billion years in producing you. It is not done with that investment yet. You have traveled far tonight, further than any distance measured in miles or kilometers or light years. You have stood at the edge of the observable universe and watched ancient galaxies forming along dark matter filaments in the universe's youth. You have watched stars burn through their fuel and become white dwarfs and cool over trillions of years into the dark. You have watched black holes sit in the silence after the last star, patient beyond patience, slowly radiating themselves away through the faintest possible glow. You have looked at the end of everything and found that it is not frightening. It is simply the universe completing what it started. A breath exhaled, fully, without remainder. A story told to its last word. A fire that burned, beautifully and completely, and then became warmth, and then became memory, and then became the quantum correlations of a universe at rest. Through all of it, every segment, every idea, every image, one thing was true. The universe is not indifferent to beauty. It produced beauty, continuously at every scale, in every era. In the ignition of the first star and the spiral arms of galaxies and the blue arcs of gravitationally lensed light, and the extraordinary, improbable emergence of consciousness in warm creatures on small planets, in quiet corners of ordinary galaxies. The universe produced all of it, and it produced you, brief and warm and aware and here. Tonight is not the ending. Tonight is the middle, the full, burning, luminous, beautiful middle of the most extraordinary story that has ever been told by matter arranging itself in the dark. And your part in that story is not finished. But tonight, your part is to rest, to give the day back to the universe that lent it to you, to let the darkness do what darkness does, hold you, restore you, prepare you for the morning that will come. Let your breath slow now. Let your body be heavy and soft and completely held. Let the thoughts drift apart one by one until there are no thoughts left. Only the quiet of a mind releasing into sleep. The universe is vast. The ending is far. The stars are burning. And you are here, safe, held, exactly where 13.5 billion years of cosmic history intended you to be. Good night, rest now. The universe will still be here in the morning. And so will you.